Yes, sir.
Good afternoon, sir. Yes, we can.
Can you all hear me clearly?
Yes, sir.
Yes, thank you. Uh, Thank you. Okay, we had some technical problems. We sort it out. Now we can start. Hope everybody can clearly hear me well. Mm, uh, right. Can you all see the screen, blackboard? Can you see the screen or the blackboard on the?
Yes, sir.
Yes, sir, we can see.
Yes, sir.
Yeah. Right. Right. Before we start, there's a instruction. Everyone, you change the name or rename it with your name as well as your registration number. Suppose that if you don't have the registration number, you better type your identity number, right? Type your identity number with the registration number. So that because it will be helpful us to trace your marks during the quiz time, so that those who have not registered can use your identity card number, right? Still, there are some without registration number. I think many. So that please rename it with your registration number, right? Or maybe with identity number. Right. Time to time, I will be telling this. Our course, basically, in terms of course evaluation, basically course evaluation will be having several components. Usually, we used to have in the evaluation, we used to have basically three components: quizzes, then we have midterm, and we have intern. That is the usual structure at PGIA level to any courses to come up with evaluation. Okay. Those who are switch on your microphone, please mute it. Otherwise, you will be disturbing the whole system. Right. Every time, keep in mind that you all are muting all the time. Right. People are joining time to time. Okay. Fine. Right. So these are the usual setup for the PGIA any courses. Since this is going to be a continuation marathon course, we thought of not having the midterm. We thought of not having the midterm examination. So we will be evaluating you all on two main evaluation, continuous evaluation, as well as the final end semester exam. I hope everyone has received the timetable. So you have received the timetable, so that timetable you can adhere to the timetable. Normally, our time schedule, Saturday from 8 to 12, and Sunday from 1 to 5 p.m. So this is the schedule for the mathematics, right? So everyone should appear on Saturday and Sunday, those who are sitting for the mathematics course. So usually, if you talk about evaluation, the evaluation will carry almost 35 to 40% of the marks from your quizzes. So that means every day you will have a quiz, at least one quiz every day. Maybe today is the first day, we don't have any quizzes. From next week onwards, you will be having quizzes. Because today is an excuse, because today is the starting day, so that you will be having quizzes. Don't write it every time. I cannot read the chat box unnecessarily, because I cannot read and wasting time. If you have any questions, you can ask, right? So don't put it in chat box, because it takes another 10 minutes wasting our time. Unless you have questions. Questions always welcome putting into the chat box. Otherwise, call me if you have any problem. Not now, not during the daytime, or not during the class time, other time, right? I cannot ask what to do, right? Okay, because there may be so many diverse people, people from 20 batch, people from 21 batch who couldn't sit for the exams, mathematics exams, etc. So different people have different problems. So I cannot solve all the problems within the class, because we will be wasting the time. So if you have any problem, call me and find out. Right. Not during the class, maybe after the class. Right. So based on this, our end semester will carry 60 to 65% marks, depend on number of quizzes, right? So this is our structure for this mathematics course, right? You can ask any questions at any time in the middle of the classes, right? So you can ask any questions with any problems that you encounter with the course, you can ask. Right. First, I will list out what are the topics that we are going to discuss, major topics, right? Because we have given only 30 hours, we cannot achieve all 30 hours. Introduction. Maybe first 2 hours we will be talking about introduction. Then we have functions or equations. Right? These are the syllabus I'm just listing out. Then we have a little bit on geometry. Basically coordinates. Then we have trigonometry. Right? Then the important aspects comes continuity, or theory of limits. Theory of limits. Then we have calculus. Basically, under the calculus, we have two arms. Differentiation, then integration, differentiation, integration. Then the last one, matrix algebra. Right? So basically, if you look at the syllabus, almost 70%, almost 70 to 80% time will be spent on these three topics, right? Mainly the calculus and the matrix algebra. Okay. Then we need some support for the calculus and matrix algebra from the introduction and the rest of the topics. So that is how our syllabus would be, right? So that if you have any questions, clarifications, I can answer. Right, we can proceed with the topics, different topics. Once again, announcement for the latecomers, those who are joining online, please type your name as well as the registration number. If you don't have a registration number, please type your identity card number which you have used for the PGIA initial information, right? So everyone, you'll have to write it down. Otherwise, we will be right. Otherwise, you will be removed from the link because we don't know unknown people, right? So everybody, right. You have plenty of textbooks available at the library. We cannot give any online, right? You can go through the library textbooks. We have a PGIA library. You go through the library and get the textbooks. And there is no any textbooks giving all these in one textbooks, right? So maybe there may be a textbook called matrix algebra. There will be a textbook called calculus, right? So understandable, so that you can go through the textbooks. Even in the website, you can get some textbooks. That is also no problem. Any textbooks will give basic information of those topics. Coming to some tutorial, maybe to work with tutorial, I'll be giving some tutorial that you can work it out, right? Maybe I can send it to our system analysis so that he will send you the tutorial. That is how it will work. Maybe I will send in the due course, maybe before next class, right? Before next class. You don't need to write or submit the tutorial. You can try for your own benefit. Tutorial will be given, right? Direct questions. Right. At the end of the course, I will come back to you how we are going to structure the final exam or the interim exam. Interim exam, some with principles, part 1 with principles, part 2 will be mainly applications. Because mathematics, most of you might wonder, if you have not gone through mathematics in your undergraduate level, you may wonder why these people are teaching mathematics. Because for any system, for any studies, mathematics is the foundation. For example, if you want to, in a plant science, if you want to measure the plants, definitely some mathematical calculations are involved, right? If you want to measure animals continuously, if you want to observe, definitely some mathematics need. In economics, if you want to look at the growth of a country continuously, you'll have to have some kind of mathematical aspects, right? Likewise, in engineering, agriculture engineering, again, the same story. When you design how to relate that particular product with the machineries, right? Some kind of calculations will be always there. Therefore, at the end, you will see how mathematics is important in a scientific life, right? Right. So starting with, I said the introduction. So in the introduction, we will talk about types of numbers. Because normally, any numbers, the system can be put into under one of these categories, right? These types of numbers, there are two main types, right? It is called as a real number and complex number, right? A real number and complex number. When you talk about real numbers are usually fractions of integrals and non-zero integrals, right? They are fractions of integrals. For example, 8 divided by 4, right? Fractions. These are called as fractions. Non-zero fractions. So this is actually 2. So 2 is a real number, right? Similarly, I mean, these are mostly integers. 8 and 4 are mostly integers. Could be some decimal values, could be. So that it is called as a real number, right? For example, 6 divided by 4. Still, it is a real number. So it is maybe some decimals also coming into picture. So this is 1.5. So this is a real number as a whole, right? Then the real number can take value from minus infinity to plus infinity by principle. Real number can take any value between minus infinity to plus infinity. The second category is called as complex number. Complex number is the number which you cannot find out solutions. For example, square root of minus 2. It's a complex number. Square root of minus 7. Again, complex number. If you have a calculator along with you, you can type and see. It will give us a syntax error in the older calculator. In the newer calculator, no solution. Sometimes it may give some values, but it's a complex number. One more thing, you can use calculators for the examination, non-programming calculators. You can use non-programming calculators, right? Right. These are the two major categories, real number, complex number. So complex number will not be divided further, but real number we can divide further into two categories. It's called as a rational number, irrational number. Rational number and irrational number. Right? Rational number and irrational number. So what are those rational and irrational number? Irrational number, for example, square root of 2, square root of 7. So what is the value of square root of 2? Square root of 2 is a irrational, sorry, other way around. No? I have put it in wrong position. So this is irrational number, square root of 2, square root of 7. These are irrational numbers. For example, what is the solution for this? Square root of 2 and square root of 7. Let's say square root of 2 is 1.4142135624, and it goes like this. Right? Then what is the square root of 7? It is 2.6457513111 and so on. Hashini, can you mute it? Hashini Abhay Singh, can you mute it? So this is called as irrational number because there's no ending. These numbers continue. No full numbers. Right? So this is called as irrational numbers. Okay? Right. Then what is Janit Ratnayaka? Can you mute it? Next time I will not tell names, I will remove it. Huh? You all are disturbing the class all the time. Since it is first day, I will allow you, but hereafter don't make any noises. Right? So the next one is a rational number. I mean, we talked about irrational number. Then we discuss about rational number. Rational numbers are normally, it can have any value, right? This can be usually fractions or could be non-zero fractions. These are real numbers. So that under rational number, there are two types. There are two types under the rational number called as integers and fractions. Integers and fractions. Okay. All right. Then under the integers mean they are full numbers. For example, it can be either negative value, or it can be either positive value, or it can be a value 0. So for example, -5 plus 8, all these are integers, no decimal points, right? Then the second group is called as fractions. Fractions, under the fractions, we have two types. One is called as terminating number. Terminating number. The other one is called as recurring, right? Reoccurring, that is called recurring. recurring number. What do you mean by terminating and recurring number? For example, 2 by 4. This is a fraction, but terminating number. What is the answer here? 0.50. So it has been terminated. So it's called as terminating number. Recurring number, let's say 1/3. So that is 0.3333 and reoccurring again the same number. Right? Under the fraction, it's reoccurring again and again. So it's called as recurring. So any number in the system can be categorized into one of these two. Any number in the system can be categorized one of these group. But don't forget that all the natural numbers are positive integers. All the natural numbers are positive integers. Right? All the natural numbers are positive integers. Right? So, Kumar Singh, can you mute it? All the natural numbers are positive integers. So, in reality, the natural numbers are always positive. For example, now number of household, number of children, number of birds, number of trees. Can I say, today I saw minus 20 trees in the botanical garden? If I say, today I saw 20 trees in the botanical garden, you can believe. But if you say, I saw today minus 20 trees in the botanical garden, it is meaningless, isn't it? Because this 0 and minus values are human intervention, or human intervene those negative and 0. But natural numbers are always positive integers, natural numbers, right? Okay. Right. So keep that in mind. Now I'm going to list out some of the examples. You can say what are those, under which category that you will list out. Let's say square root of minus 3, square root of 4, right? Square root of minus 4. Then root 3 of 8. Root 3 of minus 8. Right? Then we have pi. You might have seen all the pi. Right. Can you identify these? Can you name all these? How do you call this first one? You can answer, right? What is the first one? Yeah?
Irrational. It's a real
Irrational number.
Rational, okay. It's a rational number. What is this?
Complex number.
Hmm?
Complex number.
Why? What is the answer for square root of 4?
Rational number. Rational number.
Yeah. Under the rational number, we have several categories.
Integers.
Natural number.
Integer. Okay.
Natural number.
Integer. So what is the answer for this? I mean, in the number, what is the value?
+2 or -2.
Can't we say -2?
Yes.
Will it possible to say -2 also? -2 multiplied by -2, what is the answer? 4, isn't it? Yeah, so this can be either plus or -2, either positive or negative integer, isn't it? Either positive or negative integer. Right. What about this one?
Complex number.
Yes, it is a complex number. What about this one?
Integer.
Integer. More specifically, is it a positive integer or negative integer? It is a positive integer.
The natural.
Right? It is a don't talk about natural number. I said natural numbers are always positive integer, but not necessary to natural number. This can be artificial number. Don't say that, right? So talk about under the classification. Under the classification, it is a positive integer. What about this one?
Minus integer.
Yeah, negative integer. What about this? What is that?
Fraction.
Recurring number.
Recurring. No. What is the value? Recurring. It is not recurring.
Irrational.
Irrational number. You see, any numbers we can categorize into any of those, right? Any questions? If not, we can move to the next item. Still, we are talking about introduction. Inequalities. Inequalities. What do you mean by inequalities? Let's say x equal y. So this is we call as equal, right? So we cannot spend time because these are very basics. You can multiply and see. The answer is 2 here, right? It's a positive integer. So, right. Right. So multiply and see 2 into t, 2 into 2. That is plus 8, isn't it? If you say minus, 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 it can't be plus 8. It should be minus 8. So that is why I gave, right? So 2 into 2 is plus 8 because you are taking the root 3 of plus 8. Very basic, right? Right. Okay. This is a equal sign, right? Now let's say this is is it an equal sign? Here we say x and y are equal. Here, how do you call this sign? Anyone? Don't put it in chat. Just if you are able to answer, just answer it. Otherwise, not necessary. How do you call this sign?
X greater than Y.
Greater than. Okay. So x greater than. X is
Greater than.
higher, having higher value than y. So not an equal. So this is called as inequalities. Similarly, we could say x is less than y. How about this?
Y is greater than X.
Pardon? X is greater than or equal y. So that means x can be either equal to y or it could be above y or more than y. Similarly, we could say x is less than or equal to y. So x can be equal to y in certain occasion. The other occasion, x is smaller than or less than the, right? So these are some of the inequality signs that we can come up with. So as you all know, the multiplication rules, everybody knows that. Suppose, let's say if a is greater than 0, b is greater than 0. If I multiply a with b, so that value will be greater than 0. Right? If a is greater than 0, b is less than 0. If I multiply a with b, it is going to be less than 0, minus value. Similarly, if a is less than 0, b is greater than 0. If I multiply a with b, it is less than 0. The last one, if both a and b less than 0, if you multiply a with b, it is going to show it is greater than 0. So this is a very basic concept on multiplication rule, right? On multiplication rule, it is a very, very basic concept. Give me a second. Right. We'll continue. Suppose, let's say, x minus 3 greater than 1. X minus 3 greater than 1. So here, this is unequal sign. All right. We have an unknown, which is a variable x. Maybe today you might have heard about variable under statistics. So x is a variable. X can have several different values, right? This is a number. This is a number. So here we have a variable and numbers. So in the inequality cases, we want to bring all the variables into one side and all the numbers into other side. For example, here we have number as well as variable. So we want to get rid of the number, keep the variable only on one side. Let's say we keep the variable on the left side, keep all the numbers on the right side. So what we can do is, if I have this inequality, whatever the operation that I do on the left side, I should do it for the right side as well. Suppose how I can get rid of this minus 3. Then simply I am adding a plus 3 on both sides. If I add plus 3 on both sides, what will be the results? Results will be x greater than, you are adding 3, right? You are adding plus 3 onto the right side, so it is becoming as plus 4. Usually plus we don't indicate it. Minus, yes, we indicate it. If you see a value in mathematics without any sign, that means it is plus. If it is a minus or negative sign, it always mentioned, right? So this is the starting point for the inequalities. So this is now the inequality where x greater than 4. So if I plot it on an x-axis, right? So this is 1, this is 2, this is 3, this is 4, 5, 6, and so on. If I draw it, what are the values it can accommodate? We can draw it like this. X greater than 4. So that means 4 is not included. So I would say x will have all the values above 4, excluding a. So that x greater than. So this is how we indicate it using graphs, right? Actually, earlier case x minus 3 greater than 1. Let's say x minus 3 greater than or equal 1. Actually, when you do the operation, does not change anything. Whether it is greater than 1 or whether it is equal or greater than 1, it's more or less same answer. For example, here it says, as we already found out, x is greater than 4. Similarly, in the second case also, x is greater than 4. No difference. Greater than or equal 4. Because we have in addition to greater than and equal. So that is the case. So only in graphically we can show, in this case, it takes a value 4 as well. 4 as well as any value above 4. Right? 4, any value above. Right. Now, I will put up some examples. Try this. So you'll have to try by yourself. X minus 5 greater than 0. Find out the answer. Very simple. Mathematics, always you need to answer.
Maybe 7.
Huh?
Maybe 7.
7. X minus 5 greater than 0. So how we can get rid of this minus 5? By adding plus 5 onto the left side. So when you add plus 5 onto the left side, you have to add plus 5 onto the right side also. So what is the answer now? Camilita. Yes, what is the answer,
10.
Camilita?
X
Huh?
greater than 5.
10.
Yeah?
Maybe 10.
No, not 10.
X greater than
X
5.
greater than 5.
Yes, this is the answer is
X
X greater. Because you are adding plus 5 on both sides. Right? You are adding plus 5 on both sides. So when you add it plus 5 onto the left side, that minus 5 will cancel off. When you add plus 5 onto the right side, it will add with the 0. So that x greater than 5. Very simple. Right. X plus 1 less than minus 1. Right? Or we could write it as other way around. this we can write it as okay, minus 1 is greater than x plus 1, right? We can write it either way, doesn't matter. So what is the answer here?
X lower than minus 2.
X less than minus 2. X less than minus 2. Yeah? Because we are adding a minus 1 at a minus 1 on both sides. So it becomes as x less than minus 2. So this is correct. Right. Right. Next one. 0 greater than or equal x minus. Anyone?
X
X
less
equal
than or
and
equal
greater
4.
than
Once again.
X less than or equal 4.
X less than or equal. Let's look at it. How? Because you see here, we can add minus 4, sorry, plus 4. You can add a plus 4 on both sides, right? So it becomes as 4 greater than or equal x. Same thing which I have written. Okay, right. Now let's look at another one. 4 minus 3x greater than 2. This is a little bit deviating from what we have already discussed. Four minus 3x greater than 2. First, we can remove this plus 4. So you can add minus 4 on both sides. So it's become as minus 3x still greater than minus 2. Isn't it? So now I want to get rid of this 3. What can I do? I can either divide by 3 or multiply by 1 over 3. So then it becomes as minus x greater than minus 2 by 3. You all agree? I'm simply dividing by 3. Now you see the variable cannot be given in terms of minus, because natural events, as I said, it is always positive. So we'll have to give in terms of plus, the variable in terms of plus. So now what we want to do is we want to multiply the whole equation by minus 1. I mean minus or minus 1. We want to multiply the whole equation by minus 1. So if you multiply by minus 1, it becomes as x. I will talk about this direction of this inequality. Then 2 by 3. But keep in mind, when you multiply inequality by minus sign, when you multiply inequality by minus sign, then this direction of the inequality will change. So therefore, if you multiply by minus, the direction will be other way around. So you will end up with x less than 2 by 3. So this is the answer. right? Right. Similarly, you can try this 2x plus 3 greater than minus 1. Okay. Here we have, we add minus 3, so that 2x greater than minus 4. So x is greater than minus 4 divided by 2, which is minus 2. One more last. 5 minus 3x less than 2 minus x. 5 minus 3x less than 2 minus x. Right? So suppose we change this. Right? We can bring this minus 3x or minus x into one side. Right? Then the sign changes. For example, 5 minus 3x. Bring this x to the left side. So it becomes as plus x less than 2. Right? Now we can work it out. 5 minus 2x less than 2. Then we can apply the same condition. We add minus 5 so that it is become as minus 2x less than minus 3. So here we multiply, before that we divide by 2 so that it becomes as minus x less than minus 3 by 2. If you multiply by minus 1, become as x greater than 3 by 2. X greater than 3 by 2. Right? So here, these are the steps. So here we are adding, minus 5. Then here we are dividing by 2. We are multiplying by minus 1. Okay. So these are the steps. Sachini, can you mute it? Right. So this is the basis for the inequality. Right. Let's look at another one. It's called as simultaneous inequality. So we will do it as an example. Find and plot the solution set of the simultaneous inequalities. Find and plot the solution set of the simultaneous inequality. I will give the equation. You can try first. 2x plus 3 greater than minus 1. 4 minus 3x greater than 2. So what do you mean by simultaneous inequality? That means these two equations are going simultaneously. These two happens at the same time. That is called simultaneous. It is simple English. Right? Okay. Right. There are few members. They have not put. I have got it from the administration. They have observed that you have not included your numbers. Hasini Abhay Singh, then another Hasini, Ram Kumar, Ratnayaka, Senudi, Supuni. So these are numbers that you have not put your either registration number or the identity card number. We need those two as well, right? If you have not put the identity card number, then maybe in a couple of minutes you will be expelled from the class, because to make sure that they are PGIA students, right? So those names read out, please type your name, numbers. Your names are there. Rename it as with your name and the either registration or the identity card number. Right. What do you mean by simultaneous equation? That means they are happening at the same time. They are happening at the same time. Simultaneous inequalities. So this is an inequalities, right? So they are happening at the same time. So we want to take one by one these two. For example, let's take 2x plus 3 greater than minus 1. Right? So if you take the first inequality, we can solve the first inequality. 2x greater than minus 4. Right? From that, x is greater than minus 2. In simple steps. Similarly, take the second inequality, 4 minus 3x greater than 2, right? Minus 3x greater than minus 2. It becomes as minus x greater than minus 2 by 3. X is greater than, less than 2 by 4. So this is the answer for the second inequality. Right? Now see whether we could combine these two inequalities. That is called as simultaneous. At the same time, x is having higher than minus 2 or greater than minus 2. Meantime, x is having lower than or smaller than 2 by 3. So if you combine this, I can write it as x is less than 2 by 3, but greater than minus 2. So this is called as simultaneous inequalities. You just combine these two, isn't it? In one occasion, x is greater than minus 2. In the other occasion, x is less than 2 by 3. So if you combine, we could say x is less than 2 by 3 and greater than minus 2. If you try to draw it, right, on a scale 1, 2, 3 plus values, here 1, minus 2, minus 3. So x can have a value in between these two ranges, which we are going to indicate using the graph because we were asked to draw it. X less than 2 by 3. So let's say this is 2 by 3. So less than 2 by 3. I'm simply plotting it. And greater than minus 2, just greater than minus 2. So this is how we indicate the values for x. Graphically, we have shown. Okay? Clear? Right. Any questions? Don't put it on chat. Just ask about this question. Verbally, you can ask. Yeah.
Sir,
Yeah.
so x is
2
not
by 3
equal to
means
minus 2 means
One by one. One by one.
x is
2
not
by
equal
3
to
between
minus 2.
0 to 1. No?
I don't understand. Only one try to speak. If both try to speak, I cannot understand. Satish, tell me.
Yes, sir. X is not equal to minus 2 means, sir. Then do I need to put it into the minus 2 in the table graph?
What is that? X is?
Not equal to minus 2, right, sir?
Yeah, yeah. That is why I have drawn little right side of minus 2.
Okay.
Look at it. It is not exactly coinciding with minus 2. Just right side. Just right side. Indicating that. You understand?
Okay.
Right. Here, maybe you might see it is exactly on the line, but not really. It is little some nanometer on the right side. Huh? Yeah. Okay. Right.
Excuse me, sir. Sir,
Yeah.
in the plus side, the value should be in between 0 and 1.
Yeah. I made a mistake. Yes. In the here, let's assume this easy to draw it. I simply give me a second. I simply take this as that is what I can change. No, this is 1, right? Let's say that is 1. So this is 2 and so on. So it is this is 2 by 3. This point is 2 by 3. Okay. Yeah, you are right. You are, according to the scale, because I was thinking that is 1. Okay, thank you. Right? So you should draw it properly. Yeah? Even though I made a mistake, you draw it. Right. Let's another one. Already simultaneous inequalities on the action. So this is the question. Right. 7 minus 2x by 3 less than or equal 4 and greater than minus 3. How to handle this? This is actually a simultaneous equation which has been summarized. How to handle this kind of questions, right? So first, we want to get rid of this 3 divided by 3. So what we will do, we will completely multiply the whole equation by 3. So it becomes as minus 9 less than 7 minus 2x less than or equal 12. Isn't it? Now you can operate it. Now we want to get rid of this plus 7. So add minus 7. So it's become as minus 16 less than minus 2x less than or equal minus 7. So it becomes as 5. Okay. All right. So now we can further divide by 2. So it becomes as minus 8 less than minus x less than or equal 5 by 2. So maybe the last step, you multiply by minus 1. So it's become as 8 x minus 5 by 2. So the direction will change like this, right? Like this. So you can say x is the greater than minus 5 by x is less than 8 and greater than minus 5 by 2. Or you can do it like this. X is less than 8 if you want to rewrite it, but it is greater than or equal minus 5 by 2. Both are same. Right? Even if you write it, that is more than enough. Correct. Right. Any questions? So this is the principle behind the inequality. We are going to go a little further on inequality. So this is the starting point. Any questions? Right. Now we are going to talk about a special inequality case. It's called as absolute inequalities. What do you mean by absolute inequality? First one, we'll talk about absolute. What is absolute? Absolute value. Absolute value. For example, let's say plus 8. What is the absolute value of plus 8? This is how we indicate the absolute value. What is the absolute value of plus 8? It is 8. What is the absolute value of plus 10? It is 10. Right. What is the absolute value of minus 8? It is also 8 without sign. What is the absolute value of minus 10? It is also 10. Right? So this is called as absolute value. These are called as absolute value. All right. Absolute value is always a positive plus value. Clear? Right. Now, what do you mean by absolute value or absolute inequalities? Right. Let's take one by one. Look at very carefully. This is a bit time taking for conceptualize. Right. First, I take absolute value of x. So this is sometimes you can write it as this. So the same thing. If I write it either this way or that way, it is same absolute value. Okay. So let's say I'm going to talk about absolute value of absolute value of less than 8. This is a variable. This is a number. This is a number. Huh? Number. So any number. I will take it as A. Any number. So the absolute value of X, right? It is less than A. Understand? Our x-axis 0. I'm saying this is A. Right? This is A. That is normally plus A. Similarly, on the left side, you have minus A. Plus A and minus A. Okay? Now, look at the value of X. X is less than a particular value A. Absolute value of X is less than a particular value of A. So this is the value of A. It can be either plus or minus. Now forget about this minus for the time being and the plus, right? Forget about their sign because it is absolute value. We are talking about absolute value of X, where X having less than A. What is the area of less than A? If you demarcate, less than A is this direction here on the right side.
Right side from the
On the left side,
left side from the
here this is greater than A or less than A?
Less than.
Yeah. Here, forget about minus. Think about in terms of values because absolute value we are talking about. So here, less than A means this direction, isn't it? Because it is 1, 2, 3, 4, let's say A is 5. So all the values less than 5. Doesn't matter whether it is minus or plus, isn't it? So how we can write this in terms of X? So in terms of X, we can write this as X less than A, which is a plus A, right? And X is greater than minus A. Because now we can put it as a plus and minus in a real scale. So absolute value of X less than A can be written as such. Okay? Right. Look at the second one. Absolute value of X greater than A. Earlier one less than A. Again, we have a scale, right? We have a scale 0, A, this is minus A. For the time being, we don't put minus, right? Okay. So if you forget, if you take this as absolute value, X greater than A, can you tell me in this direction on the right side, which area is indicating greater than A? Actually, this area, isn't it? This is greater than A. Do you all agree? In terms of absolute value. Similarly, greater than A on the left side indicate this area. Isn't it? How we can write this? This we can write it as X greater than plus a, or x less than minus a. Okay, we can write it in this way: x greater than plus a, or x less than minus a. Clear? So this is called as absolute inequality. Right. Let's take two examples from this absolute inequality. First one, let's say x less than a, or I will put a number. We'll go with the number 10. X, absolute value of x less than 10. So this we can write it as directly according to the formula: x less than plus 10 greater than minus 10. Isn't it? Very simple. Similarly, if you take the second example, absolute value of x greater than 10, or I'll take another number for easiness, 8. In one case, x greater than plus 8, or in the other case, x less than minus 8. So these are the answers. These are the answers. Look at the principles. These are the answers. Right? Right. Now I will give a bit of a complicated one. Let's say x, simple one, x plus 3, right, less than or equal 4. How we can write this? First, in an earlier format, anyone? X plus 3 less than or equal plus 4 greater than or equal minus 4. Okay. All right. Less than or equal plus 4 and greater than or equal minus 4. Now, how to solve this? In an earlier way, normal way. Now we can solve in a similar way. We add negative 3, add minus 3, so that minus 7 less than or equal x less than or equal 1. So this is the answer. Right? Another example for the second one, absolute value of x plus 6 greater than. So this we can write it in two ways: x plus 3 in one occasion greater than plus 3, or in the other occasion x plus 3 less than minus 3. Now we can solve this. If it's so, how we can write this? This will be, you add minus 3 on both sides. So in first case, it will become as x greater than 0.
X plus 6.
X plus 6, no, sir.
Huh? X plus 6. Sorry. I was thinking. Sorry. Thank you. Right. Then we could say x greater than minus 3. That is one answer. Right? You are adding minus 6 on both sides for the first one. For the second one, you are adding again -3 on, sorry, -6 on both sides. In the other case, it becomes as x less than -9. So, right, you can plot it and show it, right? So I'll put up some more examples for you to try as a homework, everyone. X minus 2 less than 1, x plus 3 less than or equal 4. All right. Somebody asked, Shehan. Who is Shehan? Shehan, can we write like this? Because it says we cannot combine this, isn't it? Because this is 0, this is right. X is, sorry. Let's say this is -3, this is -9. As an example. So this says x is greater than -3. That means this area. Here it says x is less than -9. So no interconnectivity here. So somebody asked, can we write x greater than -3 less than -9? So there's no connectivity here. You see, you can't write like this because there's a gap here. No, even though it will not bring any meaning here. Because there's no any connectivity, you understand? It says x is greater than -3. This is minus, huh? -3. The other one is x is less than. Even though you can write like this, but there's no connectivity. Meaningless, redundant. Okay? Even though you write it like this, meaningless, not continuous. So you cannot write, right? But for the earlier one, yes. This one, yes, because it has a connectivity. X having a value, let's say 0. Here, let's say it is 1 plus 1. Let's say this is -7. So it is a continuity. X is less than 1. So this is this direction. And greater than -7. So this direction. So it covers almost all the area up to here. Right? It has a continuation. So that it has a meaning. But earlier one doesn't have a meaning, right? No continuation. So don't write it like this. This or that. In this case, this or that. So write it in this way, it is a mess. No continuation. By its look like it's okay, but in reality it is not giving a continuity. Right. Okay? Okay. Two different directions. Right. You have some homework. These are some homework. Let me check whether I have some more. Less than 1. Yeah. Try this one also. 2x plus 4 less than 3. You can try this. Any questions? If not, we will have a short break and continue.
මේකට අද සල්ලි දාන්නත් ඕන. ටේබල් ටෙනිස් එකටයි චෙස් එක නම් දාලානේ තියෙන්නේ.
Okay, we can continue now. Sanjeeva, can you mute it? Right. Okay. One more announcement. My class will be starting at 1 o'clock, right? Already I said Saturday morning 8 o'clock and Sunday evening at 1 o'clock. Huh? So it is fixed. So don't confuse with other lecturers. So he might start at 2 o'clock, but I will start at 1 o'clock, right? Okay. Once again, those who have not written your either registration number or the identity card number, please do it so by renaming. Right. We will continue. The next item is on equations, right? Equations. What is equation? What is equation? So from this, you could understand the term equations. What is equation? Anyone? Equation. This is an equation. So what we try to say is this is an equation, right? So we have complicated equations as well. This is a very simple one. What we try to say is an equation says two things are equal. The thing in the left side and the things in right side are equal. It says whatever on left equal to the whatever you have on your right side. So that is basically called as equation. Sometimes this equation is also called as statement. Statement. It's a kind of statement. Later you will learn how we use this statement in statistics as well as in mathematics. This is a kind of statement. How the statement can be described using these two variables, x variable and the y variable. Right? So that is basically called as equation. Right? Under the equation, we have several types of equation, starting from very simple one and goes up to a very complicated one. First one, we will learn about linear equation. රත්නායක note කරගන්න මේක තමයි ප්‍රශ්නේ මේක. ආය මකල ලියන්න වෙනවා. Right. This is the problem. Okay. Linear equation. What is linear equation? What is linear equation? The first equation which I have already given is also kind of linear equation with two variables. Suppose let's say x plus 4 equal 6. X plus 4 equals 6. So we know that x is a variable, 4 is a number, 6 is a number. To make this statement correct, because already I said that it's a statement, make this statement correct, x should have value of 1. X should have a value of 1. Anyone?
2.
To make this statement correct, x should have a value of what?
2.
Yes, 2. None of the other value for x will not make this statement correct. If you put 3, it is wrong. Isn't it? If you put 3, it is wrong. Or any other value other than 2 is wrong. So what we should do is, we should have a value for x, one unique value, only one value. So that is how the definition of the linear equation comes. So you can write down this equation. Sometimes this linear equation, also called as first degree equation, right? First degree equation is also sometimes called as linear equation. So basically, what is the definition for the first degree equation or the linear equation is only one value of the unknown will satisfy the equation right, is called as is called as linear equation. Right? So this is the simple definition. Only one value, that is more important. Only one value of the unknown will satisfy the equation is called as linear equation. So here in our earlier example, only 2 will satisfy the equation. If you put any other value other than 2, will not make that statement as a correct statement. So that only 2, right? So only one value of the unknown will satisfy the equation. So the general equation for a linear equation, a general format is given as ax plus b equal 0. So this is the general format of linear equation. So here a is the variable, sorry, x is the variable, a and b are the coefficients, or sometimes it is called as constants. A and b are constants. X is the variable, right? Dulani, mute it. Right? So here when you talk about these coefficients of this linear equation, A can have a value either plus value or minus value. A can have either plus value or minus value. Okay. Right? B can have a value either plus value or minus value or zero value. B will have a value either plus or minus or zero. So that is the difference between this value of A and B. For example, A cannot have a value 0. A will not or cannot have a value 0. Why? If A has a value 0, if this value is 0, this whole component is missing, because if you multiply this by 0, that component will be 0, so that you will end up with only one constant. Then it is no more called as equation, it is a constant. It becomes as a constant. Okay, so A cannot have a value 0, but B can have a value 0 as well as any other plus or minus value. Not necessary to have an integer, it can have any value. Okay, either integer or fraction or whatever. Right. What do you mean by, we already said equation, now solution. Solution of an equation. Solution of an equation. What do you mean? What do you mean by solution of an equation? Solution of an equation. What is that? You mean you find out the answer for a given equation. That is basically called as solution. So if you try to define the solution, what is solution? Solution of an equation, you can write it as, it is the value it is the value of the unknown which makes the equation a correct statement. Which makes the equation a correct statement. So this is very important. What do you mean by solution of a sum or solution of an equation? It says it is the value of the unknown which makes the equation a correct statement. For example, in our earlier case, value of the unknown is, so the solution for this equation is 2. So that is the value of the unknown which makes the statement correct. Okay. Right. Give me a second. Some sound is coming. Okay. Right. Okay. Let's move to the other type of equation, because we have seen only the very basic one, linear equation, the first type of equation. Let's move to the second type of equation. It's called as quadratic equation. Quadratic equation. What do you mean by quadratic equation? Quadratic equation means, I will give an example, 3x squared minus 15x plus 80 is equal to 0. Right? 3x squared plus 15x plus 18 equals 0. So here, straightforward, if I substitute values, let's say when x equal 2, you substitute the value 2 square minus 15 15 into 2 plus 18. Do that satisfy the equation? When I substitute the value 2, does it satisfy the equation? Yes or no?
Yes.
Yes. So one solution is 2. When x equal 3, again you substitute the value for x as 3 and check whether it is satisfying the equation. Simply you multiply and add the values. The left value should be equal to the right value. Anyone?
Yes.
Yes, it is satisfying the equation again, isn't it? So that is also satisfying the equation. So as we already said, those are the solutions for the given equation. This one. So what is this quadratic equation? In the quadratic equation, we also called as second order degree or second degree equation, right? Second degree equation or second order equation, right? Second order equation. So what do you mean by this? I mean, this is another synonym for this quadratic equation, second degree equation or second order equation. How we can define this? Second order equation, how we can define this? This is, it is called, I mean, if two values satisfies unknown, if two values satisfy the unknown, then it is called as second order or second degree, second order or second degree or quadratic equation. Right? So here, not like in earlier case, in a linear equation, only one value will satisfy the unknown. Here, two values can satisfy the unknown. So that is why it's called as quadratic equation. How we can generalize this equation? General form of this quadratic equation: ax square plus bx plus c equals 0. Right? So ax square plus bx plus c is equal 0. Okay? Right? Now, as you all know, x is a variable. X square and x is the format of variable. This a, b, and c are called as constants. Right? They are called as constants. All right? A can have a value, either positive value or negative value. B can have a value, either positive value or negative value or even 0. C can have a positive value or negative value or even a value of 0. But we said that A cannot have a 0 value. Why? Anyone? A cannot have a value 0. Any reason?
All value 0.
Pardon? A cannot take a value 0. Any reason?
All value can be 0.
I didn't get to your point. Rajapaksha, yeah.
All value can 0.
All value mean, for example,
X.
this one.
Yeah.
Yeah. If that value becomes 0, what is our problem? You are right. What is our problem?
All value 0.
Yeah. If this value is not there, how it look like?
Linear one.
That is the main point. If that component takes a 0 value, then quadratic form is not there. Then it is no more called as quadratic equation. Then it is becoming as another equation, but it is no more called as quadratic equation. It is a linear equation. So that is why A cannot have a value 0 here. For example, you see here, 3x square plus 4x plus 8 equals 0. Here, what is the value for A, B, and C? A is plus 3, B is plus 4, C is plus 8. Now look at here, 3x square plus 4x equals 0. What is the value for A? A is plus 3, B is plus 4. What is the value for C? What is the value for C? 0. Still, it is a quadratic equation. Right? Look at this one. A is plus 3, B is 0, C is again plus 8. So this is also quadratic equation. So we can have a quadratic equation without B and C. Right? For example, x square minus 4 is equal to 0. Possible. Right? So that is why A, we should have a value absolute. Yeah. So this kind of equation is called as quadratic. Right. Now, because in the earlier case, I simply asks you to substitute the value 2 and 3 and and see whether they are satisfying the equation. I ask you to check. Then you all checked it and it is satisfying the equation. How does we got this? How did we got this value 2 and 3? That is the next step. So that means the next step is solving the quadratic equation. So we need this information later. Solving quadratic equation. How to solve the quadratic equation? Actually, by principle, there are 4 or 5 methods available to solve the quadratic equation. First one is called as factorizing. Second one is called as using formula. The third one, taking roots. Fourth one, graphing. Graphing. The last one, completing the squares. So these are the techniques available to solve the quadratic equation. We will be talking about these 3 methods I will be showing. We will be not discussing these methods. Those are not mathematical method. Those are by using graphs and finding the area and so on, right? We will be covering the first 3, right? Let's talk about the first one. That is called as factorizing. Factorizing. Right? What do you mean by factorizing? We bring common factors. Maybe in your O level or even before that, you have done this in your mathematics course in the school time. Anyhow, I will recall one example: 2x squared minus x minus 15 equals 0. Right? So how to take the common factors? You keep this 2x squared as it is. You keep this minus 15 as it is. Right? We try to split this into 2 components. When you split this into 2 components, we want to get the common factors. For example, in this case, let's say plus 5x minus 6x. So when you add these 2, it should give minus x. Right? You can have any different format. But look at how this, why I divided into 5x and minus 6x. Look at the ratio between these 2 components. 2:5. Do you all agree? The ratio, the coefficients ratio, 2:5. What about these coefficients of ratios? Forget about minus and pluses. We will see that later. 6:15. If you divide both by 3, we could say 3:2. Sorry. Divide by 3, 2:5. So this is what we want. We break this minus x into two components where it's adjoining with the common ratio. So that is called as factorized. So that is the starting point. Look at the coefficients, using the coefficients, right? Okay. So now we can write it as 2x squared plus 5x minus 6x minus 50. Right? Now 2x squared plus 5x. Let's say minus, if you take the minus out of it, this becomes as 6x plus 50. Do you all agree? Yeah, plus 50. So these are simple mathematics. Right. If you look at it further, I'll use another color pen. Right. So here we take the common factor out. So that is x. We can take x out of it so that we can say 2x. We can say 2x right plus 5 minus, similarly take 3, right? You can write it as 2x plus 5. You see, this is a common factor. So this is how do we call it as factorizing. So since we have factorizing, we come up with the common factor. So that is the initial point, right? So you see 2x plus 5 is a common term for both two. So that one component could be 2x plus 5. The other component could be x minus equal 0. Still we are talking about 0. Right? Now we can further continue. One answer would be 2x plus 5 equals 0. The other answer would be x minus 3 equals 0. Okay? Clear? All right. Clear? So 2x is equal minus 5, where x equal minus 5 by 2. The other one is directly x equal. So here we have two answers for a given quadratic equation. So that is why we call it as it's a quadratic equation. Maybe I will do one more, then you can try this. This is you have learned. I'm just recalling it. We are not going to use this directly. Maybe once we do calculus, we need this. Without this, very difficult. Right. We will do another example. 3x squared minus 7x plus 2. So 3x we write it as it is, plus 2 we write it as it is. Now this minus 7x, how to split on a ratio? Right? How we split it? Yeah. Minus 7x. Anyone? How we can split this? When you add these two terms, it should be equal to minus 7. For example, look at it, minus x minus 6x. Because here this is ratio is fine, 3:1. Here the ratio is 3:1. Isn't it? Right, then we can go further. 3x squared minus x minus 6x plus 2. Okay? Right? 3x squared minus x is one component minus 6x minus okay, all right. So if you take this component out, so x is the common term, so that 3x minus 1 minus, if you take 2 out of it, 3x minus 1. So 3x minus 1 is the common term. So 3x minus 1 is one component. X minus 2 is the other component. Equal 0. So 3x minus 1 equals 0, one solution. X minus 2 is another solution. Right? So 3x is equal 1. So that x equal 1 over 3. Similarly, here x equal 2. So we have two solutions for a given quadratic equation. Right? So maybe I will send a tutorial. You have plenty of examples in the tutorial you can try. Right, let's move to the other method, because I already said we can use different methods to solve problem. The second one is formula, how to use the formula. Right? Before we use the formula has to be written in this format, general format. This is the general format. Any formula should be written in general format. Ax squared plus bx plus c is equal to 0. Right? Any value could be given for b and c, but a can have either positive or negative value. So based on that, the formula is as it is, x equal, you have numerator and the denominator. Numerator is minus b plus or minus square root of b square minus 4ac. Whole thing divided by 2a. So this is the formula that you should keep in mind. Right? So I will take an example, 4x squared plus 12x equals 7. So that is not enough. We'll have to bring it in this general format. What is the general format? 4x square plus 12x minus 7 equals 0. So now we'll have to identify, you see in our formula, we have three components. B is there, A is there, C is there. So we'll have to identify A, B, and C. Tell me from this equation, what are the values for A, B, and C? Value for A. Please remember, keep always touch with your sign also, whether it is a plus or minus. So A is a positive 4. What about B? Plus 12. And C is minus 7. Right? Minus 7. Now you substitute on the equation, our equation, and get the value. X equal minus 12 because it is B, plus or minus square root of 12 square, because it is a plus, so that I don't want to. Minus 4 into A is again 4 into minus 7. Divided by 2 into can you solve it? Can you solve it? You will be getting two values. Show me. I will give you a couple of minutes. You can solve it. Right, we can continue. Anyone got the answer for that? So we end up with x. I'm having a value minus 12 plus or minus. So this plus or minus, right? 16 divided by this division is for the whole 8. Right? Right. So one answer would be minus 12 plus 16 divided by 8. The other answer will be minus 12 minus 16 divided by 8. So if you go along with that, right, this is 4 by 8, one answer. The other answer is minus 28 by 8. Right, so this is half. This is 7 by 2, which is minus. So 2 answers. Right? So even using formula, you can have it, no problem. Right, the last technique, you can use the roots, taking roots. That is done only for certain cases. You cannot do it for all cases if it is a simple cases. Right? For example, x square minus 4 equals 0. So we can write as x square equal 4. Take the square root on both sides. X square equals square root of 4. So this will become as x equal plus or minus 2. So it has 2 values. Right? The second one, let's say x square minus 50 is equal 0. In the same way, we could write it as x square is equal 50. Take the square root of x square on the left side and take the square root of 50 on the right side. It can be written as x. Here, this square root of 50 can be written as 25 into 2, isn't it? So that x can be written as plus or minus 5, which is coming from 25, into square root of 2. So 2 answers will be there. Right, next one. X minus 5 whole thing square minus 100 equal 0. Another. Right? Right. So we could say x minus 5 whole thing square equal 100. Right? Then we could say, if you take the square root of both sides, so we could write it as x minus 5 is equal plus or minus 100. Sorry, plus or minus 10. One answer is x. Something wrong with the system, right? So next time we will fix it. One answer will be so here x equal 5 plus or minus 10. Okay, one answer is x equal 5 plus 10. The other answer is 5 minus 10. Okay, so from that you could say x equal 15. One answer, x equal minus 5. Right? Maybe we will take one more, last one. X minus 2 whole thing square minus 12 equals 0. Again, in a similar way, we can take x minus 2 whole thing square is equal 12. Take the square root on both sides. Equals square root of 12. So this is x minus 2 is equal square root of 12. We can say 4 into 3. So that x minus 2 equal plus or minus 2 into square root of 3. So we could say x can be 2 plus or minus 2 into square root of 3. Right? All right. So that is another way to solve the quadratic equation. Any questions on quadratic equation? Any questions? Right. You can try basically the examples given in the tutorial on both ways, using the formula or using the factorizing, right? Or factorize. So by the way, you will end up with the same answer. Right. Let's continue with the equation, maybe the last point. The third order and higher order equation. Third order and the higher order equation. This third order, because earlier one, the first order is the linear equation, second order is the quadratic equation, third order we call it as cubic equation. Cubic equation. What is this cubic equation? If I try to give you the general format of this cubic equation, right? General format of cubic equation. We could say ax to the power 3 plus bx squared plus cx equals 0. Sorry, one component missing here. Plus d is equal to 0. B, C, and D can have either positive value or negative value or even a value of 0. It's possible. A can have only either positive value or negative value. A can have either positive or negative value. Okay? Then only we can call it as quadratic equation in general. Normally, we don't use quadratic equation in this particular aspects, but we might come across with quadratic equation in matrix algebra. When we solve the quadratic equation, we will see under the matrix algebra. To solve the quadratic equation, we will see that. Right? Then, in generally, we don't use quadratic equation. Right? Now, likewise, we can write down any order equation. For the higher order equation, this is the general formula. For the higher order equation, we could say a to the power x, a into x to the power n plus b into x to the power n minus 1 plus c into x to the power n minus 2. This is how it goes on. Plus p into x plus q equals 0. So this is a general format of writing equation for the higher order. Okay? Right? So usually the higher order can be in a descending order. You see here, this is n, this is n minus 1, n minus 2, the power. Right? So this is a general term. Couple of more information about this quadratic equation, cubic equation, and linear equation. We said this is a linear equation. This is a quadratic equation. This is a cubic equation. Right? So these are the three equations that we came across in a general form. Look at their power. Power will give you some meaning. Highest order power. Here the highest order power is 1. Here the highest order power is 2 for the x variable. Here the highest order power is 3. Normally, this equation, later we will see, normally it depends if it is a turning points. For example, this is one case. This is another case. Right? This is another case. Right? So this is linear. This is quadratic. This is cubic equation. This is how the graphs look like in a very small distance. Right? This is linear. Right? Now what we try to say is, by using the higher order power, we can decide what is how many turning points are there. TP, turning points. The maximum number of turning points will be determined by what is the highest order, which is given as n minus 1. So look at the linear equation. The linear equation, what is the maximum power. What is n? N is equal 1. So how many turning points are there in a linear equation? Turning points is equal n minus 1. So we said in a linear equation, the highest order is 1. So 1 minus 1 is 0. So how many turning points are there in a linear equation? 0 number of turning points. For a quadratic equation, how many turning points are there? 2 minus 1. Only one turning point. For a cubic equation, we have n is equal 3. So 3 minus 1, 2 turning points. So these are the turning points. We have this application on these turning points. We'll see at the end under the calculus. Right. That's all about the equation. Anything very basic one? Anything you need to ask about it? Any special things you need to clarify? If not, we will move to the next section. That is coordinate geometry. Coordinate geometry. Give me a second. There's sunlight disturbing. Right, coordinate geometry. Actually, from next week onwards, we will be having quizzes. So the quizzes will be mainly based on the lectures held on the previous day. Okay. So next Saturday, quizzes will be based on what we are learning today. Okay. So that is how it will be. Okay. Right. Coordinate geometry. What do you mean by coordinate? Coordinate. What is the use of coordinates? If I say identify the location of Sri Lanka, let's say you have gone abroad, you want to introduce yourself that you are coming from Sri Lanka.
Excuse, sir.
Yeah.
So it means that next Saturday quiz will be based on this week what to learn at here,
Yeah.
class, sir?
This previous
same day.
always previous class.
Oh, okay. Okay, sir. Okay. Thank you, sir.
Saturday quiz will be next Saturday quiz will be based on today's class. Sunday quiz will be based on coming Saturday's class. Previous.
Okay,
day.
sir. Thank you, sir. Okay, thank you, sir.
Yes. Yeah. Right. So let's say you are traveling abroad and you try to explain where Sri Lanka is located to another foreign person. that foreign person, suppose, let's say, never knows about Sri Lanka, never heard about Sri Lanka, let's assume, right? So you try to explain. It is south of India, closer to India, it's in the Indian Ocean, etc., etc., etc. But still, he is not very familiar to Sri Lanka. You try to give him a direction where it's located. You can say by word, but in a world map, you'll have to explain. You don't have a map at the time, you have to explain. So how to locate it? So simply you say, he's also a science man. He knows how to latitude. Have you heard about latitude and longitude? Right? How we demarcate the Sri Lanka. So in a global map, this is the equator. This is the Greenwich Mean Time. Where we are. This is 1. This is 2. This is 3. This is 4. I mean inside. Where Sri Lanka is located, within 1 or 2, I mean 1 means here, 2 here, 3 here, 4. Where do we? Anyone? Agriculture students, geography students should know.
1.
Huh? Yes, 1. It's within 1, right? So we are somewhere here. We are somewhere here. So how we explain latitude? Latitude means it is giving the direction northwise from the equator, northwise or southwise in the from the equator. For example, we say Sri Lanka is in between 5 to there are some minutes, I don't know exactly. We don't want 5 to in between 5 to 9 degree north. Longitude, we could say it is closer to 80 and 81. 80 to 81 degree east. This is how we indicate the location of Sri Lanka. Right? So that is how we locate Sri Lanka. So this is the coordinates of Sri Lanka on a world map or global map. Right? Similarly, each and every object has to be located has to be located in a place where it could be. But how to find out these locations? Therefore, we want to use the term called as coordinates. Right? This has been initially introduced by several people, but the proper one came after some times. So it has been named as a coordinate of a person. It's called as Cartesian coordinates. It's called as rectangular. Rectangular. Cartesian. Coordinates. Right? What's rectangular Cartesian coordinates? Says you have two axes basically, x-axis and y-axis, right? Suppose, let's say you have a point here. How far this particular point P from the y-axis and how far this particular point from the x-axis. That is given as coordinates. So the coordinates, how far it is from the y-axis is given as x-coordinate, and how far it is from the x-axis, it is called as y-coordinate. So there are two coordinates. We use two-dimensional. If it is a three-dimensional, it is a bit complicated. So we stop with the two-dimensional coordinates. Sometimes we need three-dimensional, but for this course, we are talking about only two-dimensional coordinates, right? So this is called as Cartesian coordinate. So you measure horizontally from y-axis, horizontally 90 degree. Okay, you measure 90 degree from the y-axis. Similarly, you measure vertically from the x-axis, which is given as a y-coordinate. So that is called as x-coordinate and y. In a normal aspects, that is how we give the coordinates. However, there are coordinates, like I said already, how to talk about coordinates of a spherical, right? Spherical coordinate. Spherical coordinate. Spherical coordinates, like how to get a point, exactly how to refer a point. Take a football, simple form, football, how to define a point in a football, on a football. Football is a spherical, so that is basically similar to the globe, spherical coordinate, right? How to define this, right? I will simply talk about spherical coordinate, right? So we have the axis, x-axis and y-axis. So I want to specifically just a second, something went wrong with the software. I'll have to go out and come back. Huh? Just a few seconds. Software giving some problems. මෙයාට එන්න කියනවා ආයේ ක්ලාස් ගියා මේ එක එක කරදර කරලා. Okay, we will continue. Right, take spherical coordinate. What is this spherical coordinate? Spherical coordinate, as I said, to identify the points on a ball, right? Suppose, let's say, right? So these are the axis, x-axis, this is y-axis, right? So I want to find a point here. I want to indicate a point on the periphery of a ball. So that can be indicated using, for a spherical, you have a radius, right? You have a radius. Meantime, you have an angle with a horizontal axis. So let's say this is theta. So this point P here can be given with coordinates R and Q. This is how the spherical coordinate will be given as R and Q. Spherical coordinate, right? Okay. So Q is in angle, R is in distance. Normally, the angle we measure from this direction, from x-axis towards anti-clockwise always. When we come to trigonometry, we will talk about that also, right? Right. Now let's move to straight line. Now we will move to straight line. What is straight line equation? Right? Linear equation or straight line equation. I will have a drawing first. Let's take 2 points. One point is, let's say, P. The other point is, let's say, Q, right? OA. I want to connect these 2 points. I want to connect these 2 points. This point, let's say A, right? The coordinate of A is actually, this is, let's say, C. Okay. The coordinate of A is what is the value for X? What is the value for X? These are the 2 points. What is the value for X?
Zero.
X is 0, fine. What is the value for Y? Because X coordinate and Y coordinate. Value for Y is C. Similarly, the coordinate for point P, 2 points. Let's say this is right. Right. Let's say the coordinate for P is given as X and Y. Okay. It is the value for the distance from the horizontal and the vertical line, X and Y. Okay. Right. So here I have a couple of more information. First one is M, that is the slope of the line. First of all, how many points do I need to draw the straight line?
Two.
How many? Yes, two.
Two.
So these are the 2 points, P and Q, P and A. 2 points, right? I had 2 points, then I have drawn the straight line. So we need 2 points. Right, M, it is the slope. Basically, it is the change in Y divided by change in X. Let's take this junction as B, all right? So how we can define the M or the slope? We can define it as M is equal change in Y, that is PB, divided by change in X to that particular point. So AB. Okay. Right. Can you tell me PB and AB in terms of X, Y, and Z? Actual coordinate values. So this PB, what is this distance? That distance is X. Sorry, that distance is Y. Right? So this distance is X. Right? So now tell me PB, how we can write PB? How we can write PB? Anyone? In terms of
Y
X,
minus C.
Y, and C. Yeah?
Y minus this.
Y minus C. Good. Divided by, what is AB? X, isn't it? Right. If you continue further, we could say Y minus C is equal mx. From that, we could say Y is equal mx plus C. So this is the equation of a straight line. This is the equation of a straight line. This relation try to connect the C. What is C? Anyone? It's called as intercept. Intercept, right? So C is called as intercept. C is called as intercept. So here, this relation try to connect C and M. M is called as gradient or slope, right? This relation try to connect C and M with any points on the straight line, right? This is the mathematical expression of a straight line equation. This is the mathematical expression of a straight line equation. Right, now we will talk about how to develop a straight line equation. Right, how to develop a straight line equation. Let's say these are the two axes. Let's say I have 2 points. One point is with a coordinate 4 and 4, point P, right? Another coordinate somewhere here, it is with a coordinate of -2 and 1, where I say it is the Q. Now I want to draw a straight line between these 2 points, right? These are x and y axis, as you all know, no difference. This is the x axis, this is y axis, right? Now, what is the equation, straight line equation of that particular line, which connects the 2 points P and Q? How to find out? Right. Then we can come up with a simple sketch diagram. I try to draw it correctly if you see. Right. So we try to connect these lines. So we say M is equal, starting point is M, is equal change in Y divided by change in X. So what is this change in Y? 4 minus 1. 4 minus 1, sorry. Yeah, 4 minus 1 divided by this distance. What is that? That is again, that is change in X. 4 minus 2. So that is equal 3 divided by 6. Or in other terms, we found the M. We found the M. We'll have to bring it in terms of y equal mx plus c. Now, I will take a reference point somewhere in the middle, which give a coordinate x and y. Now, I try to relate these 2 points with the M. Because as you all know, M is same in any points on that straight line, which is in blue color. So slope is same at any point. So that how we can connect this, right? How we can connect this. So we can again call it for M, which is half. From earlier example we found it. Half is equal change in Y, let's say Y minus 4 divided by X minus. Sumit, can you mute it? All right. So this is, we want to get solve this equation so that we can find out correct answer. All right. So we could say Y minus 4 is equal half X minus 2. So Y is equal half X minus 2 plus 2. So that is equal Y equal half X plus 2. So this is my final equation. This is my final equation. So this is my straight line equation. Okay. This is my straight line equation. Any questions? This is how you find the straight line equation. Right. Now, if a straight line, if it passes through the x-axis and y-axis, how do we get the equation? Let's say, sorry. Let's say this is y-axis, this is x-axis. A straight line which passes through x-axis, it's given as y equals 0. You don't need the explanation. If a straight line which passes through x-axis will be given as y equals 0. If a straight line passes through y-axis, it's equation is given as x equal 0. Right? If a straight line passes through x-axis, the equation of the straight line is given as y equals 0. If the straight line passes through y-axis, the equation is given as x equals 0. Right. Let's talk about a little on parallel lines. Parallel lines. Right? So this is x-axis, this is y-axis. Let's say I have a couple of lines. This is given as y equal mx plus c. Let's say c1. Another one. So there y is equal mx plus c2. Here this distance is c2. This distance is c1. Right? The third line, let's take another line. Y equal mx minus c3. So this distance c3. Right? So what is same here in all three equations? These are parallel. All three lines are parallel to each other. So that the slope is same. So m. Only the difference where the point intersecting with the y-axis. So that is called as intercept. Right? Intercept are the differences for a parallel line. So keep in mind, parallel lines always the m is same. Right? Right. Coming to perpendicular line. Any question? What do you mean by perpendicular line? Right? So let's say I have two lines. Two lines intersecting 2 points. Intersecting at 2 points, 2 lines. Right? So when you say perpendicular, what do you mean by that? So this intersecting angle is 90 degrees. So that is why we call it as perpendicular line. Right? Perpendicular line. Let's say our original line, the slope of the original line is m, and the slope of the perpendicular line is m dash. Let's assume. right? Then if you, later we will study little on trigonometry, the angle. Suppose, let's say the angle, as we said already, it is always measured from the horizontal axis, right? So let's say this angle is theta. What is this angle? Anyone? If that angle is theta, what is that angle? 90 plus
60 plus theta.
90 plus theta. Yes, good. So 90, we usually write as pi by 2. Later in the next class, we will be talking about this. What is this pi? And so 90, we can write it as pi by 2 plus theta. Okay. Right. Now, let's look at the slope of m and the m dash. What is the relationship between those two? Slope, which is m of the original line, is given as tan theta. It is given as tan theta. Right? Slope of the m dash is given as tan pi by 2 plus theta. Do you all agree? So this tan pi by 2 plus theta, next week we will see, that is given as minus cot theta. Cot theta is 1 over tan theta. Cot theta is 1 over tan theta. Right? So that we can write it as minus 1 over tan theta. Next week we will be seeing this. Right? So we know tan theta is m. So what is 1 over tan theta? Right? M dash is equal minus 1 over tan theta. Instead of tan theta, we can write it as m. So the slope between these two perpendicular lines have interconnected. M dash, slope of the perpendicular line, is equal minus 1 over m. You should remember this, not this, but this finally. Okay? Any questions? Right. We might do a couple of examples also. Right? I'm just going through some of the theories. Then later you can. Distance between 2 points. Distance between 2 points. Suppose, let's say, you have x-axis and the y-axis. X-axis and the y-axis. Right? Okay. We have Samarajiva, can you mute it? Distance between 2 points. Let's say you have a distance from the origin of the axis. Let's say this is the point P, which is having a coordinate of x and y. So to find out the distance, we can connect these points, right? So that we could say this distance between the origin of the axis to the point P that is D, is given where with the coordinates x and y. So we could say we can use this D square is equal x square plus y square. From that, we could say D is equal square root of x square plus y square. What is this theorem? You have heard about this theorem. This theorem is based on this is 90 degree. Can you remember? How do you call that?
Pythagoras.
Yeah. Yes, but in the theorem?
Pythagoras.
Pythagoras theorem. Yes, same thing we are applying here too. Right? D is equal square root of x square plus y square. Suppose, let's say you have a point inside the axis, right? So this is x-axis, this is y-axis. Suppose, let's say I have a point here, one point, another point there, right? If you want to find out the distance between these 2 points, suppose, let's say they are having a coordinates point P1 and point P2 is having coordinates x1 and y1, x2 and y2, right? Then we can find out what is the distance between these 2 points. Right? So from that, you could say the distance here, this distance is y1 minus y2, right? This distance is x1 minus x2. Okay? Vimalaratna, mute it. Right. So that is the distance between these 2 points on the other side where we can find out the D. So we can write it as D square is equal x1 minus x2 square plus y1 minus y2 square. Okay. So that is how we can find out the D square. Then from that you can take D. Let's take an example. I have 2 points. Coordinates have been given. The first point coordinate is -1 and 3. The second point coordinate is 4 and 5. Can you find out the distance? Can you find out the distance? You don't need to solve completely, but you can find out the distance. Vimalaratna, can you mute it? Anyone? What is the answer? So it's simply, you can substitute the value. D square is equal -1 minus 4 whole thing square plus 3 minus 5 whole thing square. Right? So D is equal, anyone? You end up with an answer like this. Right? Right. Very quickly, we will go through some of the area calculation. How to calculate the area, right? Rectangle. So we know that rectangle. So this is A, this is B. The area is given as AB, right? A into B. Similarly, triangle. We take the vertical distance, which is H. The base is A. So the area of triangle is half into A into H, right? The third one is called as parallelogram. Parallelogram. What is parallelogram? Let me check whether I have parallelogram. The diagram. Yes, I have. Something like this. Right? So these sides are parallel. These sides are parallel. Right? We get the vertical height, which is H. This distance is A. So the area is given as A into H. The last one on the area, trapezium. Trapezium. Right? What is trapezium? This is what we call as trapezium. Only one side is parallel. These sides are parallel. So we take the horizontal distance, right? That is H. This distance is A. This distance is B. right? The area is given as half into A plus B into H. Okay. All right. Right. Give me a second. Right. The next one is intersection of lines. Intersection of two lines. What do you mean by intersection of two lines? If there are two straight lines, they can intersect at a particular point, right? Suppose, let's say I have two lines. One line is this. The other line is, let's say, this. Suppose, let's say, the equation of these two lines are 3x minus y minus 5 is equal to 0. That is the equation of first line. The equation of the second line is 2x plus 3y minus 7 equals 0. This is the equation of the second line. Now, I want to find out what is the intersecting point with these two coordinates. Right? What is the intersecting point of these two coordinates? All right? Okay. To find out the intersecting point of these two coordinates, we have two equations. First equation is 3x minus y minus 5 equals 0. Second equation is 2x plus 3y minus 7 equals 0. Right? So we want to solve these two equations. So that is how we can find out. This is the first equation. This is the second equation. So we can solve these two equations. Right? For example, if I take the first equation, if I multiply this equation by 3, become as 9x minus 3y minus 15 equals 0. Take the second equation, 2x plus 3y minus 7 equals 0. So this is equation number 3, equation number 4. Right? We add equation number 3 and 4. If you add these two equations, it becomes as 11x minus 22 equals 0. So 11x is equal to 22, x becoming as x becoming as 2. So once you get the x as 2, substitute on this equation, any of those equations, and get the y value. Can you substitute and tell me what is the y value?
One.
1.
One,
Good.
sir.
So y will be 1. So this is the intersecting point between two lines. So here the x value is 2 and y value is 1. So that is how you find out. So the intersecting point need not to be perpendicular, any intersecting point, right? Look at this question. This is homework for you all. You can try. Find the equation of the line going through the point 4 and 5 and perpendicular to the line two x minus 3y equals 6. So this is the question. You can do it as a homework, but I will give you steps. You can try. Find the equation of the line going through the point 4 and 5. So let's say we have coordinate, doesn't matter whatever the point. Let's say 4 and 5. So that is the coordinate with 4 and 5, right? A line which goes through the 4 and 5, right? And meantime, it's perpendicular to the line 2x minus 3y equals 6. So let's say there's an original line, right? So this is 2x minus 3y equals 6. That is the straight line. So the new line, which has to go through that particular point, as well as perpendicular to the red color line. So if I draw it, that line, it will give a line something like this. So here, I want to find out the equation of this line, which is perpendicular to the earlier line. So this point is this intersecting point, right? Sorry, not intersecting. This is a line. I mean, this is the point 4 and we don't know. What is the intersecting point? We don't know exactly, but it is passing through 4 and 5. That is the information that has been given. This blue color line is passing through 4 and 5. Meantime, it is perpendicular to 2x minus 3 equals 6. So we were asked to find out the equation of the blue color line. What are the steps? Anyone? So your MCQs will be in this format. I mean, quizzes will be in this format. So what is the first step? It has to be done through 2 steps. It should be done through 2 steps. What is the first step? What is the first step?
Finding the slope.
Yeah, slope of
Finding
which?
the slope of this perpendicular line. Already we studied m1 equal to minus 1 over m. So
Yeah,
using
that is fine. Before that,
we have to find what is the format of the red color line. So we can arrange that.
exactly. So first we'll have to find out the m. That is the slope of the first line. Then, as a second step, we need to find out the slope of the second line or perpendicular line. So we know the relationship. M dash is equal minus 1 over m. If you know the m, because we can, from here we can find out the m. If you know the m, we can find out the m dash. If you know the m dash, we have one point here. Take another point, a reference point, x and y, and we can relate that with the slope. That is how it works, right? So you can try that, and if you need, we can get the answer next week. Right, any questions? Any specific questions on what we have discussed?
Sir, could you please repeat this again, that last?
First, we have to find out the slope of the red line, red color line, which we can find out from this equation, right? We can bring it in that format. We can bring it in that format. We can find out. Right? Then, once you know the m, from this equation, we can find out the m dash. So that is the slope of the line that we want to find out. Once you know the slope of that line, take another reference point as x and y and try to relate it as I did it at the beginning, right? Because m dash is equal y minus 5 divided by x minus 4. So we'll have to find out this m dash, what it is. If we know the m dash, we can, this is the last step actually, right? Then we can find it. There was a question, query about the quiz. Just a second. A suggestion, can't we have the quiz based on the same day contents? Who wants that? Do you want to have the quiz on the same day content or previous day? For me, it's not a problem at all.
Previous days.
Previous day, sir.
For me, it doesn't matter. For me, it's the number of quizzes. For me, it's the matter of number of quizzes, whether it is same day or previous day will not make any differences for me, number of quizzes, right? But if you wish, I can have from the same day, because there was a chat from the one of the participants. Can't we have quiz based on the same day content? Because on a a polite basis, I thought of for the people who are learning for the first time, you can look at your notes and some referment with that you can do the quiz. That is what I thought. But if you wish to have on the same day, fine, no problem. Yeah, I see most are coming with the previous day, so we will go along with that decision, right? For me, it doesn't make any difference, huh? Right, okay, then see you next Saturday. Okay, bye then.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.